Hey everyone, welcome to Simplilearn. Today we will be learning hashing concepts in cybersecurity. So let's try to understand the concept with the help of an example. So this analogy will help demonstrate how hashing works in a more intuitive way. So imagine you're helping to organize books in a bookstore. There are hundreds of books and you want a system that allows you and customers to find books quickly. In this case, the hash function is a simple rule that determines where each book should be placed based on its genre. So let's say you have genres like fiction, non-fiction, science, history, and romance. So each genre corresponds to a specific section of the bookstore. When a new book arrives, you look at its genre. A book like Pride and Prejudice falls under romance category. According to hash function, that is genre to section mapping, this goes in the romance section. And a book like A Brief History of Time by Stephen Hawking is a science book. So it goes into the science section. So now we'll see how we can handle collisions. So there are collisions in hashing. We'll see what it is and how does it occur. So collision happens when two books belong to the same genre and therefore are assigned to the same section. For example, 1984 by George Orwell and To Kill a Mockingbird by Herbert Lee are both fiction and will share the fiction section. Since collisions are expected, that is, many books can share a genre, you can further organize each section by author's last name or book title alphabetically. So, how this example relates to hashing? So, first we'll talk about hash function. So, this method of determining the book's placement based on genre acts as a hash function. It takes an input, that is genre, and maps it to an output, that is bookshelf section. Now we talk about efficiency. So this method allows you to quickly sort and locate books, similar to how hashing in computing enables fast data retrieval. And talking about collision handling, so just like in computing, where hash functions need methods to handle collisions like chaining or open addressing, in the bookstore you use alphabetical order within each genre to handle multiple books of the same genre. And moving forward, we'll discuss about these collisions. So don't worry, we'll discuss about them. And now talking about scalability. So as the collection grows, the basic hashing system, that is genre-based sections, remains effective. And further subdivisions like alphabetical sorting help maintain order and efficiency. So why we use this method? So the reasons are, number one is quick access. Customers and staffs can find books quickly by heading straight to the relevant genre section. Number two is organized space. The bookstore is neatly organized, making it visually appealing and functional. Then comes the scalable system. As more books are added, they can easily be incorporated into the existing system without needing a complete recognition.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
And before commencing, guys, just a quick info for you. If you're an aspiring cybersecurity professional looking for online training and certification from prestigious universities and in collaboration with leading experts to enhance your credibility, then search no more. Simplilearn's postgraduate program in cybersecurity from MIT University in collaboration with EC Council should be your right choice. For more details, use the link in the description box and pinned comment. And if these are the types of videos you would like to watch, then hit the subscribe button, like, and press on the bell icon to never miss on future content. So let's get started. So here we have understood hashing with the help of an example. Now we'll have an introduction to hashing with the definition. So hashing in simple terms is, it's a process used in computing to quickly locate and store data. Imagine you have a huge library of books and you want to find a particular book or put a new book in the exactly right place without searching through every shelf. So hashing is like creating a unique code for each book based on its title that tells you exactly where it should go on the shelves. So this code is generated by what we call a hash function. So let's move to importance of hashing in computer science and data processing. So hashing is essential because it allows computers to manage and retrieve data very effectively. So now we'll discuss some of the few reasons that's why hashing is crucial. Number one is speed. So hashing significantly speeds up data retrieval, making it possible to access information almost instantly, which is crucial for performance in software and web applications. Then comes consistency. Hashing ensures that data is always stored and retrieved in the same way, which helps in maintaining order and predictability in complex systems. Then comes security. In security applications, hashing is used to encode sensitive information like passwords. Once hashed, these passwords are not easy to reverse, which means even if someone gets access to the hashed password, they can't easily decode it to find out the original password. So now see where hashed values are stored. So hashed values are typically stored in a structure known as a hash table. So a hash table is an array of buckets or slots where each bucket can hold one or more records. So when a hash function processes an input like a password or a database entry, it produces a hash code, which then determines in which specific bucket the record should be placed. This system of using hash codes to quickly locate data slots makes retrieving data much more straightforward and faster. Now, continuing from our introduction to hashing, let's delve deeper into some basic concepts that make hashing an effective tool in computing. So now we'll see the applications of hashing in real life. So hashing is a powerful tool used in many real-life applications to make processes more efficient and secure. Here are some key areas where hashing plays an important role. Number one is data retrieval. So hashing is widely used to speed up the process of finding data. When you look something up in a dictionary or a phone book, you don't go through every entry. Instead, you jump directly to the section you need. So hashing does something similar with digital data. Example, imagine a library system where books are sorted not just by titles, but by unique codes generated from the titles. These codes help the librarian quickly locate any book without scanning through every shelf. Number two is security. Hashing is crucial for protecting sensitive information, such as passwords. When you create a password, it's hashed and stored, not the actual password. When you log in, the system hashes the password you enter and checks it against the stored hash. For example, when you sign into your email, the system doesn't compare your password directly to what's stored. Instead, it hashes your entered password and compares this hash to the stored hash. So this way, even if someone accesses the stored data, they won't see your actual password. Now coming to number three, that is digital signatures and integrity checking. Hashing ensures that the data has not been tampered with during transmission. Digital signatures use hashing to verify the integrity and authenticity of a message or document. For example, when you download a software update, the provider might give you a hash of the file. After downloading, you can hash the file and compare it to the given hash. If they match, you know the file is intact and has not been corrupted or altered. Now coming to number four, that is hash tables in programming. So hash tables or hash maps are a common data structure in programming that uses hashing to quickly store and retrieve values. This is essential for databases, memory caching, and many algorithms. For example, suppose you are developing an application that needs to manage a large set of users. Using a hash table, you can quickly look up user details by hashing their user ID to find the corresponding data in memory, instead of searching through the entire list of users. Now coming to the next, that is blockchain and cryptocurrencies. So hashing is fundamental to the functioning of blockchain technology, which underpins cryptocurrencies like Bitcoin. It ensures the integrity of transactions and blocks, making the blockchain secure and tamper-proof. For example, in Bitcoin, each block of transaction is hashed, and this hash is included in the next block. This chaining of hashes ensures that altering any block would require changing all subsequent blocks, which is computationally impractical. Now moving to the basic concepts of hashing, and let's see what is a hash function. So a hash function is a special formula used in computing to quickly turn any kind of data like a name, a file, or a password into a small fixed size hash code. This hash code acts like a shortcut. So a hash function is a special formula used in computing to quickly turn any kind of data like a name, a file, or a password into small sized hash code. This hash code acts like a shortcut that helps the computer quickly find out where this data is stored in its memory or check if two pieces of data are the same without having to compare them directly. So now we'll see the properties of a good hash function. So a good hash function has several important properties that ensure it works well and securely. Number one is determinism. This means that no matter how many times you use the hash function on a particular piece of data. It will always give you the same hash code. For example, every time you hash the name Alice, you should always get the same result. Then comes the next function, that is uniform distribution. A hash function should spread all the data evenly across all the available hash codes. This avoids clustering of data in certain parts of the memory, which can slow down the system. It's like making sure no single shelf in a library gets overcrowded with books. Now coming to the next property, that is non-invertibility, that is one-way function. A hash function should be difficult to reverse. That means if you have the hash code, it should be really hard to figure out what the original data was. This is especially important for securing sensitive information like passwords. So now we have understood the properties of a good hash function. Now we'll move to the hash collisions. So what are collisions and why do they occur? So collision in hashing happens when two different pieces of data produce the same hash value. Imagine you have two different people with different names, but their names end up being stored in the same spot because the hash function gave them the same hash code. This happens because the hash function can only create a limited number of codes. So sometimes different data can end up with the same code. Now we'll see how we can handle these collisions. So the number one method to handle these collisions is chaining. So chaining is a way to handle collisions by storing multiple pieces of data in the same spot. So let's see how it works. So if we have two different names that end up with the same hash code, both names are stored in a list at that spot. For example, think of a mailbox where you can put multiple letters. If two letters are supposed to go to the same mailbox, you just put both of them inside the same box. Now coming to the second method, that is open addressing. So open addressing handles collisions by finding another empty spot in the hash table. So let's see how it works. So when a spot is already taken, the hash function looks for the next available spot to store the data. Example, imagine a parking lot where each car is assigned a spot. If a spot is already taken, you find the next free spot and park there. If spot 5 is taken, you try to take the spot 6 and so on until you find an empty one. So these were the methods. With that, you can handle collisions. So salt and peppering are methods used to make hashing more secure, especially for passwords. So the number one method, that is salting. So this method, what it does is it adds a random value, that is salt, to the data before hashing it. This makes it harder for attackers to guess the original data. For example, if your password is my password, the system adds a random string like 1234 before hashing it. So it hashes my password 1234 instead of just my password. So now coming to the next method, that is peppering. So adding a secret value, that is pepper, to the hash which is kept secret and not stored with the password. For example, it's like adding a secret ingredient to a recipe. The pepper is a value known only to the system, making it even harder for attackers to crack the hash data. Now that we have covered the basics of hashing and how to handle collisions, let's look at some of the most popular hash functions used in the world of computing. So the most popular hash functions are, number one is MD5, that is Message Digest Algorithm 5. MD5 is one of the oldest and most widely known hash functions. MD5 takes an input, that is message, and returns a fixed size string of 128 bits that is usually represented as a 32 character hexadecimal number. So its typical use is, it was commonly used to check the integrity of files and to ensure data that hasn't been corrupted during transmission. For example, when you download software, the website might provide you an MD5 hash so you can verify that the file you received is exactly the same as the one on the server. So due to vulnerabilities found in MD5, such as the ability to produce the same hash value for different inputs, that is, there occurred collisions. It is no longer considered secure for cryptographic purposes. Then comes another method or another hash function, that is SHA-1, that is Secure Hash Algorithm 1, and it's the another older hash function that was widely used for many years. So SHA-1 produces a 160-bit hash value, typically represented as a 40-character hexadecimal number. So its typical use was, SHA-1 was used in security applications and protocols, including TLS and SSL, for securing data transmission over the internet. So like MD5, SHA-1 has been found to have significant vulnerabilities, and it is no longer recommended for security sensitive applications. It has been replaced by more secure versions of the SHA family, that is SHA-256. Now we'll see this application, that is Secure Hash Algorithm 256-bit. So it is a part of the SHA-2 family and it is widely used today due to its strong security features. So SHA-256 generates a hash value of 256 bits represented as a 64 character hexadecimal number. It is designed to be much more secure than MD5 and SHA-1. So its typical uses, SHA-256 is used in various security applications and protocols including SSL, TLS for secure internet connections, Bitcoin and other cryptocurrencies for securing transactions, and in digital signatures to verify the authenticity of documents. And SHA-256 is considered highly secure and is recommended for use in situations where data integrity and security are paramount. Now, if we do a simple comparison of hash functions, so to help you understand these hash functions better, so MD5 that creates a 128-bit hash, good for checking data integrity but not secure for cryptographic uses. SHA-1 that creates a 160-bit hash, more secure than the MD5 but still vulnerable to attacks. Then comes the SHA-256 that creates a 256-bit hash, very secure and widely used in modern applications for ensuring data integrity and security. So this was all about hash functions. Now moving to hashing in artificial intelligence. So hashing is not only essential in data storage and security, but also plays a crucial role in the field of artificial intelligence. So let's see how it makes AI or uses AI to make processes more efficient and manageable. Number one is feature hashing for dimensionally reduction. So in AI, particularly in machine learning models that often need to process large amounts of data with many features or attributes, sometimes the number of features can be so large that it makes the model slow and difficult to manage. So feature hashing, also known as the hashing trick, helps solve this problem by reducing the number of features. So feature hashing transforms the feature into a fixed size array or vector of a specified length, regardless of the original number of features. It uses a hash function to map each feature into one of the positions in this array. For example, imagine you have a data set with thousands of unique words. Instead of creating a spreadsheet column for each word, which would be enormous, you use feature hashing to map these words into a smaller fixed number of columns, and each word gets hashed into one of these columns, effectively reducing the number of dimensions. And the benefits are, this reduces the memory required and speeds up the computation, making the model more efficient without losing too much information. Then comes reducing data complexity and enhancing scalability. Hashing also helps in reducing the complexity of data, which is crucial for making algorithms faster and more scalable. So how does this do it? So number one is simplifying data. So by converting complex data into simple hash codes, hashing makes it easier for AI algorithms to process and analyze the data quickly. This is particularly useful in tasks like image recognition, where large and complex data sets are common. Then comes scalability. Hashing allows AI systems to handle large volumes of data efficiently. For example, in large-scale recommendation systems used by companies like Netflix or Amazon, hashing helps manage and retrieve user data swiftly to provide real-time recommendations. Then comes speeding up search and retrieval. Hash functions allows AI systems to quickly find and access data. For example, in natural language processing (NLP), hashing can be used to index and retrieve text data swiftly, improving the performance of search engines and chatbots. Now we'll see the practical demonstration to understand how hashing works in practice. So we'll look at a simple coding example in Python and we'll create a hash table and use a hash function to store and retrieve data. So let's see that. So moving to Visual Studio Code, I have the function here. So you could see that we have written a code here and we have provided a hash function to calculate the hash value of a given key. And we have created a hash table that will represent as a list of lists to handle collisions using chaining. So what we are doing is defining a simple hash function here. So this function calculates the hash value for a given key and table size. So this is the function header defining the hash function. It takes key and table size as parameters. Then we have hash value, that is this line converts the key to an integer by summing the ASCII values of its characters. Then we are returning it, that is this line returns the hash value modulo the table size, ensuring the result fits within the bounds of the hash table. Now what we are doing is defining the hash table size, that is this line sets the size of the hash table to 10. Now we'll create an empty hash table that we have created, and now we will insert the function, that is this function inserts a key value pair into the hash table. And now we'll define the retrieving function, that is this function retrieves the value associated with a given key from the hash table. That is, this is the header and then we have the index. So this line calculates the hash value for the given key, and this loop iterates over the key value pairs in the list at the calculated index. And if kv, that is this condition, checks if the current key matches the given key, and if a match is found, this line returns associated value, and if no match is found, this line returns none. And now we'll insert some data into the hash table. So these lines insert 3 key value pairs into the hash table, that is apple that have 1, banana 2 and cherry 3. So now we'll retrieve the data from the hash table. So we are printing the values, that is for apple, banana, cherry and grape. So in summary, you can see, I will run the code for you guys. As we have declared the key value pairs for apple, banana and cherry, and there was no for grape, you could see that it has returned apple 1, banana 2, cherry 3 and grape none. So this code example demonstrates how to create a hash table, insert data into it and retrieve data from it using a simple hash function. So the hash function ensures that each key is mapped to a specific index in the hash table, making data retrieval efficient. So with that guys, we have come to the end of this session. If you like this session, please like, share and subscribe. And if you have any doubts, please comment down in the comment section below.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.